Regarding shark species that depend on ram ventilation, their advantages. They can efficiently take in substantial quantities of oxygen when moving at high velocities, establishing themselves as nimble predators that dominate expansive open waters. Sustained swimming also assists some warm-blooded sharks, like the great white, in maintaining a stable core body temperature, a phenomenon termed regional endothermy. This physiological adaptation allows them to hunt effectively in colder waters and sustain elevated levels of metabolic activity. Moreover, their constant movement enables them to scour vast territories for sustenance, sometimes covering hundreds or even thousands of miles annually during their migratory journeys. They are truly the ocean's indefatigable warriors, perpetually in motion to achieve their objectives, much like a high-performance race car, perpetually demanding fuel. Their drawbacks. This reliance on movement constitutes their Achilles heel. They can swiftly become exhausted and succumb to asphyxiation if ensnared in fishing nets, suffer injuries that impede their swimming capabilities, or are simply apprehended and held immobile. This inherent vulnerability also renders them more susceptible to anthropogenic fishing pressures. The demanding existence of a professional aquatic athlete can indeed be rather harsh. For example, a great white shark caught in a fishing net can rapidly accumulate an oxygen debt and perish within mere minutes if its ability to move is compromised. Regarding shark species proficient in buccal pumping, their advantages, these species can comfortably rest, thereby conserving vital energy and effectively conceal themselves from potential predators or unsuspecting prey. The capacity to breathe while stationary grants them access to and exploration of intricate habitats such as coral reefs, submerged caves, or areas characterized by sluggish currents where continuous swimming is neither practical nor necessary. This remarkable adaptation enables them to exploit a broader spectrum of food sources that are inaccessible to obligate ram ventilators, such as crustaceans nestled within rocky crevices. They are superb hiders, favoring stillness and patience, genuinely embodying the maxim of resting to accrue strength. Their drawbacks. The buccal pumping mechanism is generally less efficient at facilitating high-speed oxygen uptake. Consequently, these species tend to be slower moving and cannot sustain elevated speeds for prolonged durations like their more athletic counterparts. They are perfectly suited for ambush predation or consuming slower-moving organisms. While they may not be clinching any gold medals in grand oceanic swimming races, they are impeccably adapted for their precise ecological niches. In conclusion, the widely propagated notion that sharks must ceaselessly swim to remain alive holds for only a subset of species. The vast majority of shark species possess the ability to respire while stationary, a testament to biological mechanisms precisely tailored to their distinct habitats. This pervasive misapprehension is not merely a simple misunderstanding. It carries profound implications for how we perceive and, crucially, how we protect these vital marine creatures. By gaining a nuanced understanding of the diverse respiratory strategies employed by sharks, we not only cultivate a more accurate biological perspective, but also deepen our appreciation for the astonishing adaptability each species demonstrates within its unique environment. Sharks are far from mere, tireless swimming machines. They are intelligent, diverse beings who have mastered the art of survival, whether through constant motion or by simply enjoying a well-deserved, leisurely underwater repose. It is high time we discarded these outdated narratives and embraced an updated comprehension of these magnificent fin companions. Within the immense and enigmatic expanse of the ocean, a conviction has profoundly rooted itself in the human psyche. Sharks are impervious to cancer. The imagery of these formidable monarchs of the deep, enduring for millennia untouched by this dreadful affliction, has ascended to legendary status. even serving as the foundation for a contentious shark cartilage therapy industry. Yet, does this represent an astonishing scientific revelation, or merely an exaggerated narrative born from limited comprehension and a hint of fanciful romanticization surrounding these creatures, akin to the whimsical belief that consuming carrots guarantees flawless night vision? The prevailing notion that sharks are immune to cancer is unequivocally incorrect. While the occurrence might be less frequent in certain species compared to other vertebrates, cancerous conditions undeniably manifest in sharks. The idea that sharks never develop cancer likely stems from the infrequent observation of tumors in these animals. Nevertheless, since 1908, researchers have meticulously documented instances of cancer in sharks, including the formidable great white sharks, tiger sharks, blue sharks, reef sharks, and even the humble dogfish sharks. These neoplastic growths have been discovered in various anatomical regions, ranging from their integumentary system and hepatic tissue to their nervous systems, reproductive organs, and even cartilage. It appears, then, that cancer is quite determined to seek out these aquatic inhabitants, displaying an utter disregard for their ancient lineage. One might jest that cancer operates as an equal opportunity employer. This widespread misapprehension largely stems from the publication of the book Sharks Don't Get Cancer in the 1990s, which subsequently gained considerable traction in popular media, fueling a surge in the market for shark cartilage supplements. Extensive scientific inquiry and rigorous clinical trials have, however, comprehensively disproven the efficacy of shark cartilage in either treating or preventing cancer. Adhering to these unfounded assertions not only results in financial waste, but can also tragically lead patients to forego effective conventional medical interventions, culminating in regrettable and sometimes devastating outcomes. Clinical trials have consistently demonstrated no discernible therapeutic benefit of shark cartilage across various human cancers, and in some instances, its consumption has been linked to adverse effects such as nausea, vomiting, and debilitating fatigue. While not entirely resistant, sharks do appear to exhibit a heightened resilience to cancer compared to certain other animal species. This intriguing observation has left scientists pondering, eager to unearth any concealed biological advantages within their immune systems and physiological makeup. The unique evolutionary trajectory of sharks, having diverged from other vertebrates over 400 million years ago, suggests that their immune systems may have independently cultivated distinctive mechanisms for robust disease resistance. The shark immune system, though often characterized as more rudimentary than that of mammals, demonstrates remarkable efficacy. Sharks belong to one of the most ancient vertebrate lineages possessing a fully adaptive immune system, strikingly similar to humans, complete with B and T lymphocytes. A particularly distinctive feature is the presence of unique forms of antibodies, specifically single-domain antibodies, which remarkably lack the light chains found in mammalian antibodies. The diminutive size and singular molecular architecture of these antibodies enable them to access and bind to challenging targets that larger antibodies cannot effectively reach, including cancer cells nestled within the intricate tumor microenvironment. This represents a clandestine biological arsenal that researchers are assiduously working to harness for human medicine, particularly in the advancement of novel immunotherapies for cancer. These IGNARs exhibit exceptional stability and demonstrate a superior ability to penetrate tissues more effectively than conventional antibodies, positioning them as highly promising candidates for innovative drug development. Furthermore, comprehensive genetic investigations into sharks have yielded captivating revelations. Certain genes associated with immune system function and cell cycle regulation in sharks display unique adaptive traits. For instance, genes such as legumine and bagone, which are implicated in human cancer development when overexpressed, exhibit signs of positive natural selection in sharks. This may suggest a divergent role or a more stringent regulatory mechanism within sharks, enabling them to more effectively control anomalous cellular proliferation. In essence, even when cancer attempts to infiltrate their physiological defenses, shark organisms appear to possess more efficient internal checkpoints to repel the onslaught. Researchers are diligently sequencing the genomes of diverse shark species to precisely identify and characterize these specific genetic adaptations. Another contributing factor, strongly linked to sharks' disease resilience, is their extraordinarily rapid and efficient wound healing capabilities. Their astonishing capacity to recover from significant injuries could be intricately connected to a robust immune system and a superior ability to regulate inflammatory responses, both of which are critical determinants in thwarting cancer development. They possess a multitude of genes involved in blood coagulation and tissue regeneration, facilitating swift recuperation from physical trauma. This remarkable ability not only empowers sharks to thrive in demanding oceanic environments, but also contributes substantially to their potential resistance to cancer. Given that chronic inflammation is a well-established precursor to numerous cancers in other animal species, however, it is crucial to underscore that the environmental habitat of sharks may also play a contributory role. Residing in vast, expansive open waters might imply a reduced exposure to certain carcinogens compared to terrestrial animals or those inhabiting polluted coastal ecosystems. This environmental aspect could also contribute to the relatively low incidence of cancer observed in these creatures. A precise understanding of sharks and their relationship with cancer not only helps us dispel harmful misconceptions, but also carries profound ramifications for global conservation initiatives. When erroneous assertions of cancer immunity and shark cartilage cure all gained traction, millions of sharks were mercilessly slaughtered for their cartilage, driving numerous species to the brink of extinction. This not only wreaks havoc upon delicate marine ecosystems, but also constitutes profoundly unethical conduct founded upon false information. The precipitous decline in shark populations directly attributable to this misconception has had severe ecological consequences, given sharks' indispensable role as apex predators in maintaining overall ocean health. Instead of senselessly hunting sharks under the delusional premise of a miraculous cure, our focus should unequivocally shift toward conducting more intensive research into their unparalleled immune systems. Their inherent disease resistance, remarkable capacity for rapid wound healing, and specialized genetic mechanisms are collectively unveiling promising avenues for modern medical science, aiding our comprehension of cancer and facilitating the development of efficacious treatments for human ailments. Sharks are not merely simple biological tools for healing. They represent a living repository of invaluable biological knowledge. Safeguarding them means safeguarding a precious resource for scientific advancement and the enduring health of our entire planet. We must rehabilitate their reputation and accord sharks the profound respect they inherently deserve, rather than viewing them as a mythical panacea for all human maladies. When contemplating sharks, the popular imagination frequently conjures an image of a solitary predator, silently navigating the vast ocean, devoid of companionship or peers, driven solely by the stark imperatives of survival. This ingrained belief that sharks are lifelong recluses has deeply permeated public consciousness, perhaps influenced by horror films that depict them as devoid of emotion and mere killing machines. But does this truly reflect the existence of these ancient mariners? Or is it merely another amusing misconception about our finned acquaintances? akin to the widely held but incorrect notion that cats despise water? The actual truth, it turns out, is considerably more intricate and profoundly captivating. The assertion that sharks are solitary creatures throughout their entire existence is entirely unfounded. While it is true that some shark species may spend the majority of their time independently, particularly during hunting excursions, a wealth of scientific evidence demonstrates that their social interactions are far more complex and varied than previously imagined. Branding all sharks as perpetual loners is equivalent to assuming all humans are hermits, necessitating no interaction or connection with others. Such a blanket statement sounds rather antiquated, does it not? Recent advancements in acoustic tagging and underwater telemetry have provided unprecedented insights into the hidden social structures of many shark species. Scientific inquiry has conclusively shown that numerous shark species exhibit surprisingly sophisticated social behaviors, ranging from assembling in vast aggregations to cultivating more enduring relationships. A compelling illustration of this phenomenon is the hammerhead shark. Specifically, great hammerheads are renowned for congregating in schools, comprising hundreds, sometimes even thousands, of individuals at specific oceanic locales, such as the Cocos Islands off Costa Rica or the Galapagos Reefs. Scientists continue to meticulously investigate the precise rationale behind these monumental gatherings for reproductive purposes, to facilitate more efficient hunting strategies, or perhaps as a defensive maneuver, seeking safety in numbers from larger predators, or even potentially serving as a navigational aid. Irrespective of the underlying impetus, these colossal meetups unequivocally reveal a profound absence of solitary existence. Such large aggregations also likely play a critical role in facilitating genetic exchange, promoting greater population resilience, and may even enable the transmission of learned behaviors across generations. Even species traditionally considered solitary harbor their surprises. Sand tiger sharks, for example, have been observed establishing elaborate social networks, forming groups of up to 200 individuals, and even appearing to maintain persistent friendships with specific individuals they encounter repeatedly throughout the year. Or consider the lemon shark, which similarly displays a remarkable aptitude for forming bonds, selecting companions of comparable size, and engaging in frequent interactions, even without an obvious direct benefit to survival. It certainly sounds as though they have established their exclusive social clubs deep beneath the waves, doesn't it? Even the formidable great white shark, widely recognized as a solitary hunter, has been documented congregating in particular hunting grounds where they can establish discernible social hierarchies and avert conflict by deferring to one another. It appears even the ocean's undisputed monarchs understand the importance of minding their manners.